Exercise 1.2, question number 2. Question number 2 says we have to decide whether set A and B are equal sets or no, and you need to give reason for your answers. Set A says even prime numbers, and set B is x says that 7x minus 1 is 13. The only prime number that we have learned is 2. So set A contains an element 2. Set A is a singleton set. Let's solve for set B. 7x minus 1 equal to 13 means 7x will be 13 plus 1. 7x will be 14. X will be 14 upon 7. X answer will be 2. That means B will contain an x which satisfies this equation, and the x value comes out 2. So the element in B will be 2. Again, B is a singleton element. If you observe A and B, they both are singleton set and both consist of the same element 2. So we can say that set A is equal to set B. Let's go to question number 3, which says which of the following are empty sets, and give a reason for that. The first one says A consists of all the A's such that A is a natural number smaller than 0. We know very well that natural numbers start from 1, 2, 3 and so on till infinity. So if you observe carefully, there is no natural number smaller than 0. All the natural numbers are bigger than 0. So set A is an empty set. Since we cannot find a natural number smaller than 0, you can write a reason over here. Since no natural number is smaller than 0. So we have A as the empty set. Let's go for second question. B is equal to x such that x square equal to 0. The only number which can satisfy the equation x square equal to 0 is x equal to 0 itself. 0 square gives you 0. So the solution of the equation x square equal to 0 is 0. So set B contains a single element 0. So B is a singleton set. B is a singleton set. The question says whether the set is empty or no. So you write the answer over here. No, set B is not empty. Let's see the third question. The third question is C is equal to x such that 5x minus 2 equal to 0 and x should belong to natural. Let's solve the equation 5x minus 2 equal to 0. 5x will be plus 2. X will be 2 upon 5. So we have the answer of x is 0.4. When you divide 2 by 5, you get the answer 0.4. And 0.4 is not a natural number. 0.4, I repeat, 0.4 is not a natural number. It's a decimal number. So set C will not have any x which satisfies the equation 5x minus 2 equal to 0 and x should belong to natural. So set C is empty. The final answer will be therefore set C is empty set. Now let's go to the fourth question. The fourth question says that with reason you need to write whether the sets are finite or infinite. Let's start with the first question. The first question says A is equal to x such that x is less than 10 and x is a natural number. That means you have to list all the natural numbers which are less than 10. So we know that natural numbers start from 1. So let's write the number 1, which is obviously less than 10, then 2, then 3, then 4, then 5, then 6, then 7, then 8, and then 9. Till 9 we have numbers less than 10. We cannot include 10 over here because we need numbers strictly less than 10. So the set A consists of elements 1, 2, 3, 4, 5, 6, 7, 8, 9, which is a finite set. So set A is a finite set. Now let's see the second question, that is B is equal to Y such that Y is less than -1 and Y is an integer. We have already learned the integers. The integers are numbers on the number line which you have learned if you remember properly. In the center we have 0, then on the right hand side we have positive numbers 1, 2, 3 and so on, and in the left hand side we have negative numbers -1, -2, -3 and so on. These are the integers. So if you need the integers which are less than -1, that is, you need to list down all the integers which are on the left side of -1. As you know very well, on the number line the numbers increase when you move towards right. If you go towards right, the number increases. When you go towards left, the number decreases. So if you need numbers which are less than -1, that means you need to jot down all the numbers which are on the left hand side of -1. So let's write down set B. Set B will have numbers from -2, -3, -4 and so on till infinity. So if you'll observe, set B is an infinite set. Now let's see the next set, which says set of students of class 9 from your school. Now we know very well that the class 9 of your school can be easily listed or can be found out with the help of the attendance register, and it can be counted. So set C is a finite set. The same logic you can apply for people from your village. People from your village can be counted and which are maintained regularly yearly on a census basis. So we have people from your village can be counted. So we call this set as finite set. Then we have the next question, which says set of apparatus in laboratory. As we know very well, there are many apparatus in the laboratory, but those apparatus record is properly maintained by the lab attendant. So therefore we can say very well that the apparatus in the laboratory can be counted and can be recorded and kept. So we call this set as finite set. Set of whole numbers. Set of whole numbers. Whole numbers start with number 0 and onwards. 0, 1, 2, 3, 4, 5 and so on. This is set of whole numbers, which you can very well see is an infinite set. So set of whole numbers is an infinite set. The next is set of rational numbers. Set of rational numbers in definition. Rational numbers are all those P upon Q kind of numbers where P and Q belongs to integers and Q should not be equal to 0, which indeed is a very much kind of infinite set. These numbers cannot be counted. They are placed on the number line between two natural numbers. So set of rational numbers is an infinite set. So here we come to an end of practice set 1.2. Hope you understood the sums. Write down practice set 1.1 and 1.2 in your notebook along with the type of sets and the definition of equal set. Thank you and God bless you.